Okay, so we can start. নেটটা খুব স্লো আছে বুঝলে। Find the find the find the SHM of the spring. Or sorry, question is find the simple harmonic motion time period of oscillation of the block. Means we stretch that block by a y distance and release, so it will moving to and fro motion. Find the time period of oscillation. So how you solve this question? As it is given, y is the distance moving downward by this one, and let k is the spring constant, and let y1 is the distance traveled by the spring. It is very clear, if that distance is traveled y, this one is connected with the spring, so y travel double distance. Now let T is the tension. So if this is the tension T, so these two tensions are T1, T1. T1 is T by 2, which is equals to the spring elongate KY1. So tension on the spring is 2KY1. That is 2KYA1 is 2Y. So you have 4KY. So your tension is 4KY. Now due to this tension, that tension and this Y is always opposing, or you can say this force is always opposing. So my force, that is mass into acceleration, minus 4KY.
স্যার
হ্যাঁ,
ওটা t/2 কেন হলো টেনশন 1 টা?
আরে এটা যদি t নিতিস তাহলে এটা 2t হতো, এটাকে t নিলে এটা t/2 হবে না?
হ্যাঁ হ্যাঁ আচ্ছা
Okay, after that দেখো next part which is very very important.
স্যার ky' কেন হলো?
আরে এটা যদি y যাচ্ছে তাহলে এটা তো সেম যাবে না, এটা ডাবল যাবে না, দুটো স্প্রিং আছে তো,
স্যার কিন্তু t/2 টা তো তুমি এক একটা ধরলে না।
হ্যাঁ।
আচ্ছা দুটো অ্যাড করে দিয়েছে পরে।
হুম। আচ্ছা, now see a very very important thing, that is whenever we write a wave, A is the amplitude. Suppose we can write sine or cos omega t plus or minus phi. We know this one. Plus means the phase difference is lead, minus means the phase angle is lag. Now here in this all symbol has their own meaning, like phi, that is the change in flux. If we say, means if you want to compare it with respect to the any other one, so change in flux is 2 pi by lambda into del x. What do you mean by del x?
Path difference.
Suppose this is my wave path difference. If I start from here, that is called the del x. Okay, means path difference. Then we know omega 2 pi frequency, very very important term. Apart from that, see, this one is a very very important thing. Suppose I am writing omega t plus phi. This is my equation given. Okay, and this is my equation given, and make it 0. So when you make it 0, what happened? Omega t plus 2 pi by lambda x equals to 0. That means my x is what? Negative value. What do you mean by my x is negative? That means my graph, you know this from the electromagnetic wave also. This is my x-axis, this is my y-axis. Why? Because y is here, and this is suppose given 2 pi by lambda x. That means the wave is propagating along the y-x axis, and negative, that means the wave is traveling in which direction? In negative x-axis. Okay, everyone? Hello.
Yes, sir.
Next important part is omega t, that is angle, and 2 pi by lambda into x, that is also angle. So what do you mean by omega? 2 pi frequency time equals to 2 pi by lambda x. Now 2 pi frequency t equals to 2 pi by lambda into x. So now we can differentiate this. Once we differentiate, what we have? 2 pi f dt by dt, that is 2 pi by lambda dx by dt. We can cancel this 2 pi dt by dt is 1. So f into 1 is 1 by lambda. Dx by dt is called the velocity. So velocity equals to frequency wavelength. This velocity is called the phase velocity. And I think you are very familiar with this equation, C equals to F lambda. Remember? Hello.
Yes, sir.
Now, apart from that, suppose suppose one more very important thing. Suppose y is a function that is a sine omega t minus 2 pi by lambda x. Okay. Now, if we differentiate this with respect to time, so what we have, a, this sine become cos omega t minus 2 pi by lambda x, and when we differentiate that part, we take extra omega, so we can write a omega, and the maximum value, that is a omega. So this velocity is called the particle velocity. Means the way the particle is vibrating to and fro motion. That is not the speed of the wave. That is the vibration of the wave. The vibrational speed of the wave. That is called the particle velocity. Now the acceleration dv by dt, that is d square y by dt square. So we again differentiate this, and we know differentiation of cos is minus sine, so minus a, and you take extra a omega square sine omega t minus 2 pi by lambda x. One more thing, if you want to check that whether these things are whether these are satisfying simple harmonic motion or not. So it's a very simple way you can check it. Suppose this is my y. So once I differentiate this, see this value is exactly same, yes or no? So I can write c d square y by dt square equals to minus omega square y. So yes, simple harmonic motion, yes or no?
Yes, sir.
And this one is called the particle acceleration. So if anyone asks you what is the maximum particle acceleration, if anyone asks you what is the maximum particle acceleration, so I can easily say my maximum particle acceleration is omega square. A is the amplitude, yes or no?
Yes, sir.
Now try one numerical. Now try one numerical. The numerical is that y is given 4 sine 2 pi t by 0.02 minus x by 100. The equation for the displacement of a straight string is given by above formula, where y and x are in centimeter. Y and x are in centimeter, t in second. Okay. Determine number one. Direction in which wave propagating. Direction in which wave propagating. Number 2, amplitude. Number 3, angular frequency. Number 4, time period. Number 5, frequency. Number 6, wavelength. Number 7, propagation constant, which is called represented by k, that is 2 pi by lambda. Propagation constant. Number 8, velocity of the wave. The velocity of the wave है, that is the phase velocity. Okay, the wave कितना speed से जा रहा है. Then number 9, maximum particle velocity. And number 10, maximum particle. तो देखो ये एक क्वेश्चन से ऐसा 10 क्वेश्चन, different type of question they can ask you. Any one question they can ask you and you can give the answer. So this is a very, very important. Try and tell me what is the answer. I give you 5 minutes for that. Interference, superposition, যে কোনো wave, ওখানে তো interference means in optics that is the transverse wave, but not necessary for the transverse wave. Here the same thing, but for any wave. Okay, so when we superimpose two wave, we know we get the final wave A sin omega t plus or minus del. Now how we get A? We know from the previous class, previous means LA ka, the amplitude of A1 square, amplitude of A2 square, 2A1 A2 cos phi. और मुझे basically यही चाहिए और कुछ नहीं चाहिए. Amplitude and this del. So del is tan inverse A sin A2 sin phi by A1 plus A2 cos phi. So basically what happened? So I think all of you remember this one, and to remember this for any time, you can use one more method, that is vector method. We know if R1 and R2 are two vectors, then the resultant vector is A square plus B square plus 2AB cos theta, and the angle is B sin theta by A plus B cos theta. So similarly, we can do that. And you know for this key, what do you mean by constant? क्या था वो? Constructive wave, destructive wave, when the phi is maximum value, when the phi is minimum value. I think all of you know that ki phi cos phi when 1, then you get the value of the phi is n lambda 2n pi, that is 2 pi by lambda into del x. I hope you all remember this one. Del x is n lambda. This is the path difference, this is the phase difference for constructive, and in that case maximum amplitude A1 plus A2. And if you remember, the intensity is directly proportional to amplitude square, intensity is Ka square. I think all of you remember, so we can use this one also. Yes or no?
Yes, sir.
तो देखो इसमें honestly speaking इस सुपरपोजिशन वेव्स में मुझे बताने का कुछ नहीं है. I already say you everything in the chapter सुपरपोजिशन ऑफ वेव्स इन ऑप्टिक्स. मैंने इसका सब कुछ इंटेंसिटी निकालना, एम्पलीट्यूड निकालना, मैक्सिमम मिनिमम सब कुछ बताया था. मैं अभी जो नेक्स्ट जाने वाला हूँ वो है यस सबसे जो पहला है दैट इज फर्स्ट वन इज velocity of transverse mechanical wave wave इस ट्रांसवर्स मैकेनिकल वेव में क्या है कि सपोज तुम्हारा पास एक वेव है and that is you can transverse means propagating. So velocity of the wave का जो formula है root under T by mu, where T is the tension on the string, mu जो है mass per unit length of the string. So इसके ऊपर देखो दो बड़ा सुंदर सुंदर क्वेश्चंस है. First question is using this formula. First question is एक inclined plane है, angle of inclination is 30 degree. यहाँ पे एक block है. Let the mass of the block is m1, which is connected with the string, and here the mass of the block is m2. Now the question is that a wire of mass means mu is given at 10 to the power minus 2 kg per meter passes over a frictionless pulley fixed on the top of an incline. This one incline frictionless plane, which makes an angle 30 degree with the horizontal. Masses m1 and m2 are tied at the two ends of the wire. The mass m1 rests on the plane and m2 hangs vertically down. The whole system is in equilibrium. That is very, very important. The whole system in equilibrium. The whole system is in equilibrium. Now a transverse wave is propagating on the wire with the velocity. ये जो tight wire हो गया, इसमें एक transverse wave propagate किया है, जिसका speed है 100 meter per second. Now the question is that calculate the mass m1 and m2. Calculate the mass m1 and m2. So what we have to calculate? We have to calculate the mass m1 and m2 का value. So first of all, see, if we use this formula, so velocity equals to root under T by mu, which is 100, equals to T we don't know, but we know 10 to the power minus 2. So after squaring both sides, we have 10 to the power 4, T by 10 to the power minus 2. So T equals to 10 to the power 4 into 10 to the power minus 2. That is 10 to the power 2 Newton, 100 Newton. So once I get this, tension on the string is T. Once I get this value, this is M2G, and this is inclined plane, no friction is there. So M1G sine 30 degree. So what we can say, tension equals to M2G, which means 100, M2 into 10, that means M2 10 kg. Now tension M1G sine 30 नेटवर्क पे এত খারাপ হয়ে আছে
স্যার স্ক্রিনটা চলে গেল
হ্যাঁ 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 হ্যালো হ্যাঁ গুড মর্নিং ও আচ্ছা হ্যাঁ স্যার বলুন 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 বাবা আমি রেকর্ডিং অনই করিনি আচ্ছা সো bulk modulus is pressure P, and as the bulk modulus is pressure P, now velocity of sound is bulk modulus by rho, that is P by rho. Now for air, okay, for air, what happened? The pressure is 1.01 into 10 to the power 5 Newton per meter square, that is 1 atmospheric pressure, and density of air is 1.3 kg per meter cube. So what we get, 1.01 into 10 to the power 5 by 1.3, the value is 279 मीटर पर सेकेंड. लेकिन देखा क्या गया है इन रियलिटी में कि velocity of sound at 0 degree centigrade is 332 meter per second. तो ये होना चाहिए था और ये आया. That means there is something wrong. Yes or no? Yes or no?
Yes, sir.
तो इसको करेक्ट किया लैप्लास ने. लैप्लास करेक्शन. तो लैप्लास ने क्या बोला? लैप्लास ने बोला कि when sound propagates through a gaseous medium, when sound propagates through a gaseous medium, it does not take enough time to exchange heat with the surrounding. So क्या है? The adiabatic process. So when sound propagates through a gaseous medium, याद रखना adiabatic. किसके हिसाब से? लैप्लास. और न्यूटन के हिसाब से आइसोथर्मल. तो ये सब बात याद रखना कि किसके हिसाब से बोल रहा है. अकॉर्डिंग टू लैप्लास एडियाबेटिक प्रोसेस. और एडियाबेटिक प्रोसेस में क्या होता है? एडियाबेटिक प्रोसेस में क्या होता है कि Pv to the power gamma is constant. We know this. So when we differentiate, keeping P constant, we can differentiate gamma V gamma minus 1 dV plus V gamma dP equals to 0. And when we solve this, you just remember in this way, dP by dV minus, पहले क्या था? P by V था. यहाँ पे P by V के साथ एक एक्स्ट्रा गामा आ जाएगा. So my bulk modulus, that is minus V dP by dV, is minus V minus gamma P by V, that is gamma P. So bulk modulus मेरा आ गया gamma P. So my velocity is root under B by rho, that is gamma P by rho. ये मेरा formula है. And if we want to put this now, so pressure is 1.01 into 10 to the power 5 Newton per meter square. Rho is 1.3 kg per meter cube. And gamma, देखो एयर में क्या होता है? ऑक्सीजन होता है. तो ऑक्सीजन का मतलब क्या? डाइएटॉमिक का गामा क्या होता है? याद करो 7/5 1.4. So velocity of sound is 1.4 1.01 10 to the power 5 by 1.3. इसका जो वैल्यू आएगा, it's approx 332 meter per second. So Laplace correction is right. Okay, when sound propagates through a gaseous medium, it is an adiabatic process, not isothermal process. Okay, and the velocity of sound is 332 meter per second. अब देखो इस Laplace correction के ऊपर बहुत सारा क्वेश्चंस होता है. हाँ, सबसे तो पहले ये जो मैंने वेलोसिटी ऑफ साउंड लिखा है, that is gamma p by rho, तो इसको हम लिख सकता है गामा p के जगह पे nRT by rho into वॉल्यूम. और rho into वॉल्यूम क्या होता है? rho into वॉल्यूम होता है मास. अच्छा, नंबर ऑफ मोल क्या होता है? मास बाय मॉलिक्यूलर वेट. सो मॉलिक्यूलर वेट क्या हो जाएगा? मॉलिक्यूलर 1 बाई मॉलिक्यूलर वेट क्या हो जाएगा? n बाई m. सो ये n और m को हम चेंज कर सकता है. सो गामा RT बाई मॉलिक्यूलर वेट भी मेरा वेलोसिटी हुआ. गामा p बाई रो ये भी मेरा वेलोसिटी ऑफ साउंड इन गैसियस मीडियम, एंड दैट इज longitudinal wave, not the transverse wave. these are longitudinal wave and velocity of sound is this gamma p by rho. तो इसमें एक और बात है कि गैसियस मीडियम में होता है ये, और स्ट्रिंग माने सॉलिड मीडियम में वेलोसिटी होता है t by mu. जैसे खूब स्लो है, t by mu ये हो गया सॉलिड मीडियम. याद करो अभी हम लोग पढ़ा था जैसे स्ट्रिंग है, ठीक है, कोई बार है, तो इसमें होगा सॉलिड मीडियम पे ये, और गैसियस मीडियम पे ये होगा. और इसके अलावा तुम लोगों को मैंने काइनेटिक थ्योरी ऑफ गैस में बोला था एवरेज वेलोसिटी, मोस्ट प्रोबेबल वेलोसिटी, हाँ, और क्या एक तो था आरएमएस वेलोसिटी. तो इसके साथ साथ तुम इसको भी यूज कर सकते हो साउंड के लिए, गामा पी बाई रो. ठीक है. अच्छा, अपार्ट फ्रॉम दिस, इसके साथ छोटा बहुत सारा कॉन्सेप्ट के ऊपर क्वेश्चन देता है. जैसे पहला क्वेश्चन है, from this we can say velocity is directly proportional to temperature root under t. So velocity at any temperature by velocity at 0 degree centigrade, that is 273 plus temperature by 273. If we suppose the Kelvin scale 0 degree मतलब 273 डिग्री सेंटीग्रेड, so ये कितना आया 1 plus t by 273 हाफ. तो देखो एटमॉस्फेयर का टेम्परेचर कितना होता है 10, 12, 15, 20, 25, 30. with respect to 273 it's a very less value, so we can use binomial theorem. So we get 1 plus t by 546. So velocity, that is v naught 1 plus t by 546. अगर मैं velocity at 0 degree centigrade, अगर मैं velocity at 0 degree centigrade को 332 1 plus t by 546 करूं, तो 332 plus ভাল লাগে না, নিজের থেকেই চলে যাচ্ছে আজকে বারবার. तो 332 plus 332 by 546t, 332 plus 0.61 t. So this is the velocity of time. देखो you can use directly. Suppose बोला कि 0 डिग्री सेंटीग्रेड से velocity of time टेम्परेचर को मैंने 10 डिग्री बढ़ाया. So what is the change in velocity? So 10 डिग्री का बढ़ाया मतलब 0.61 into 10, that means 6.1 मीटर पर सेकंड का वेलोसिटी बढ़ जाएगा. क्लियर?
Yes, sir.
अच्छा, नेक्स्ट इज ह्यूमिडिटी is inversely proportional to density, and here see velocity is inversely proportional to density. So अगर मेरा ह्यूमिडिटी बढ़ेगा तो डेंसिटी घटेगा, अगर डेंसिटी घटेगा तो वेलोसिटी ऑफ साउंड इंक्रीज. क्लियर? सो वेलोसिटी ऑफ साउंड इज डायरेक्टली प्रोपोर्शनल टू ह्यूमिडिटी. जितना ज्यादा ह्यूमिडिटी होगा उतना ज्यादा वेलोसिटी ऑफ साउंड होगा. क्लियर?
Yes, sir.
And the last one for today, that is the pressure. वेलोसिटी ऑफ साउंड देखो यहाँ पे तुमको फंसाएगा. हम बार बार बोल रहे हैं, क्यों? क्योंकि हमें पता है कि गामा आर टी बाई एम एंड एट द सेम टाइम गामा पी बाई रो. तो यहाँ पे वो फंसाएगा तुम्हें. कैसा फंसाएगा? वो बोलेगा एट कांस्टेंट टेम्परेचर pressure become 2p. How the velocity of sound change? और यहाँ पे एक ऑप्शन में रहेगा v, एक ऑप्शन में रहेगा √2 भी मोस्ट ऑफ द स्टूडेंट डायरेक्ट इसको मानेगा क्योंकि उसको याद है वेलोसिटी इज √Γ p/ρ, लेकिन नहीं, अगर मेरा कांस्टेंट टेम्परेचर बोल रहा है, कांस्टेंट टेम्परेचर बोलने का मतलब है कि अगर मैं प्रेशर को बढ़ा रहा हूं तो क्या हो गया, वॉल्यूम एट द सेम टाइम घट जाएगा। सो दैट मीन्स हम बोलेंगे कि एट कांस्टेंट टेम्परेचर प्रेशर is independent of velocity of sound। ठीक है, अगर कांस्टेंट टेम्परेचर बोला है तो प्रेशर पे डिपेंड ही नहीं करेगा, प्रेशर को बढ़ाओ घटाओ कोई फर्क नहीं पड़ता है। क्लियर? ओके, ठीक है। सो दैट्स इट फॉर टुडे।